one-way moment from webinar 1 was related to leadership and governance and working together as a team. And this one-way moment, I want to talk more about caring for our people and the environment, to take that kind of team-level discussion to the next phase. So often, as a team down, when we make procedures and policies and plans that are meant to be implemented, but unless we actually implement them, follow on the implementation, we might ensure it's happening, and it may not be happening appropriately. So one thing that we do here with Attenuation is we have these discussions that are called Serious About Zero, or SAZ discussions. The purpose of these discussions is to keep, again, health, safety, and care environment at the forefront of our minds and the work that we do. Encourage people to have conversations about both positive and potentially corrective measures that can be taken towards health and safety and environmental protection. Engaging all personnel within their workplace, office, or field, and even at home, recognize good safety practices, proactively controlling hazards and risks, and encourage active and open discussion and problem solving. This is an example of, what client site this is, but a situation where it's important to recognize that we have followed through on some of the policies that are developed, and make sure people are actively talking about in their environment. This is a press release. It was recently painted, and the procedures were in place where that the valves be checked weekly, there were no obstructions, and really that procedure is being followed. So that's worth a conversation on how to ensure safe practices in our workplace. So the 6 steps of our SAZ conversations are to prepare, observe, initiate, agree, and commit, record, and close out. And recently we've moved to an online recording system that can be an app on our cell phone to help increase the use of these SAZ conversations and document them so that we can kind of track early indicators for health and safety. Okay. To move to the technical working group and the invited attendees, and we'll do a quick introduction. So in front of you is a list of the invited attendees for today's discussion, and who I confirm is online is we have Kiki, a water engineer from the city of Surrey. We have Vinny Sivia from the Fraser Health Authority, and Mark Zubel, Fraser Health Authority as well. And I have not received confirmation from Kiki that Jeff Arison is participating, but he did respond that he would participate, so hopefully he's not online yet. He will join us shortly. From the city of White Rock, we have Sad Jassim, and from New Zealand, we have myself, Margaret Scott, the lead hydrogeologist, Leader Hammond, the hydrogeologist, Lucian Linus, and the ground modeler, Webb. The roadmap to ask for protection, where we are today. Stage 1 was to identify stakeholders to be engaged with, gather data, and develop a conceptual model. Stage the technical working group to talk through the plan for the development of the Aquifer Protection Plan and the data that had been collected and conceptualization to date, to give an opportunity for familiar with the area to provide some input or identify data gaps that they can help fill. Stage 2 is to conduct predictive modeling and develop groundwater management and sustainable development goals. That's what's going to be discussed today in the technical webinar, and we will take information and feedback from today, help tweak our Aquifer Protection Plan, and prepare for a public open house, and ultimately the final report. So we have a technical webinar today. Webinar 2 objectives. We'll get started by first going over what was discussed in webinar 1. Talk through clear engagement, as I said, the data gathering, conceptual hydrological model, and then the building of the 3D numerical model, and identification of the potential contaminants. That was all discussed in webinar 1. going to talk through the predictive modeling results, so identify the well capture zones and the operational scenario, including potential impacts from climate change on groundwater availability, sustainable development, risk identification, groundwater management strategies, contingency planning, and data collection program. And this particular, I hope to have a good discussion on, because this is where input from the technical working group would really help to better develop these groundwater risk identification and the groundwater management strategies. The presentation over to my colleague Zidra, and we'll walk through the predictive modeling results.
Okay, Margot. Right, we have considered two scenarios for modeling purpose. So the first scenario, or the baseline case, is future water demand up to 2045. So this is consistent with planning that has been done as part of the City of White Rock's Water System Master Plan update. This accounts for population growth, changes to use, and water loss. We also include groundwater planning that has been done by the municipality and what they plan to date. The scenario includes the same groundwater extraction from scenario 1, but we incorporate some aspects of climate change. That includes increasing the seasonal demand for the City of White Rock water supply system, and also changes to recharge. And for the purpose of this study, we've done it based on projected precipitation for the 2020s. I'll get into a bit more background on what the 2020s mean in some slides that are coming up. And we also incorporate sea level rise. So just back to this. So each of these bullets I'll discuss a bit further to provide some background on what each of these mean. For future water demand, this is for the City of White Rock. The study that's been done by Kerwoodell has projected demand, and we've basically taken that and shown it graphically here. So in upper right-hand corner, we show annual demand, and we show levels in 2017, and then we also show levels predicted at the end of our modeling here for the baseline scenario and then the climate change scenario. So there is an increase from 17 to baseline, and there's also a slight increase from baseline to 2045 when we look at annually. But to get a better picture of what this means for ground extraction, we have to look at it in on a monthly time scale. So the graph below shows ground extraction on a monthly time basis. The baseline is shown in the blue line, and then climate change is shown in the red hatching. And so basically baseline and climate change follow the same water use, except for when groundwater is used during to meet sea demand. And so that's where you see these peaks happen during the climate change scenario. So that's in May, June, July, and August, where we have an increase in water demand. And that's some people using it for irrigation purpose, to water gardens or the grass, that kind of thing. And now we've taken these trends for annual and monthly, and now we've applied it to each of the wells for the City of White Rock existing network. And so we've taken the percentage for each well is based on average well use from 2012 to 2016, and shown in the lower right-hand corner. And, we've replaced well 5, which is no longer in use by the City of White Rock, with well 8. So this, we can see that number 4 is not used very regularly, just to help meet seasonal demand, and the other wells are used quite regularly, with well 8 having the highest usage for the future. And so our scenario, or baseline scenario, also considered groundwater extraction from planned by the City of Surrey. The Surrey plans to supplement their water supply from Greater Vancouver Water District with groundwater. They have plans for 2 locations. So the Sunnyside Acres Urban Forest Park, which is in this area. They also have plans to develop a well in Fleetwood, which is to the north of our area on the other side of the Nickel River, at a site called Fleetwood. But that's not included in our model because it's outside our model domain. And so they plan to, sorry a second here, get my notes. Anticipate to start withdrawals in 2023, and they plan to have a constant extraction, so the minimal or no seasonal variation, and that's what we know so far. I don't know, Kay or Jeff, if you have any additional comments to future ground use by the City of Surrey.
Yeah, you hear me?
Yes.
That's good. Yeah, the 2 side wells, number 2 and number 3, they are all located in the inside park, and yeah, it would be starting. We intend to start the pumping in 2023, and we continue.
Okay, thanks for that. And so now for scenario 2, we've incorporated climate change. And this is quite a detailed topic, so I will cover it briefly just to get the main points of what we've considered. So I guess the more recent climate change projections include these 3 scenarios, or these 3 types of times. So that's this RCP 8.5, RCP 4.5, and RCP 2.6. For our purposes, we've considered RCP 8.5. In this case, we do the global climate models. This considers business as usual. And, this is consistent with most current public policy planning. The other scenarios, so RCP 4.5, have a lower emission scenario, and that's with assumed medium stabilization of greenhouse gases, whereas RCP 2.6 is substantial and sustained reductions, and this is consistent with the most recent Paris agreement. So our approach takes sort of worst case in terms of climate change. And the figures to the right, the top figure shows some output from various climate models for each of these different climate scenarios. And I just wanted to highlight that there is uncertainty with global models. And the global models simulate complex processes, and there's a range of possible outcomes. So just to highlight, there is some uncertainty, and we've tried to, I just wanted, yeah, I guess that's important to understand. And then now the graph on the lower right-hand corner. So in climate change, there's a talk on the 2020 different periods within the climate model. And so for the purposes of our study, we're considering the 2020. So this is generally a 30-year period within future projection of the global climate model, where averages are taken out. So it's similar to the normal that are used with our climate data that's prepared by Environment Canada. In our approach, we looked at 3 global simulation models from the most current Intergovernmental Panel on Climate Change assessment report, so that's assessment report number 5. We have taken downscaled climate data sets from Climate BC, and we've looked at downscale data, and we've compared it to normals for climate station in White Rock, and then we've applied shift factors to avoid any bias in the downling method. So this is an approach that is used to address some of the uncertainties in the global circulation models. This slide now presents the outcome of that. So right here we have two graphs. The upper graph shows the projected change in precipitation for the city of White Rock. Now shown the timescales that are to be used for climate change analysis, so the 2020s, the 2050s, and the 2080s. And to get an idea of, working at the 2020s, because that corresponds with the planning that is currently done by the city of Rock. But in the 2050s and 2080s, we normally need a longer-term view. So just to get an idea of what's to come. So it's showing here that, I'll maybe just step back once and discuss the graph on the bottom. So this shows the change in the projections compared to the normals for the climate station at the city of White Rock. So the bar above zero indicate an increase in precipitation, and the bars below zero indicate a decrease. So in general, the annual precipitation is only comparable, what's projected for the 2020s compared to what we're seeing, compared to normals that we see now. But if we look at this more on a monthly time scale, then we see some interesting things happening. So precipitation is projected to increase from September to January, but it just decreases during the spring and the summer. So what this means is that drier conditions are expected in the summer for the White Rock area, and this could mean that increase in seasonal demand is likely. So people need to water their gardens or their lawns more often to account for less precipitation during the summer in the White Rock area. And so does climate change impact recharge? So we've assumed that 23% of precipitation occurs as recharge in our model based on a study conducted by Gardner-Lee for the city of Surrey. And that results, and then we apply that to precipitation that was projected in the future to calculate our recharge. So what this means is that annually the recharge is pretty similar for existing conditions and then what's projected in the 2020s. Monthly, there's a graph on the slide that just shows there is some variation in the monthly values, and just to highlight that in June, July, and August, so in our drier part of the year, we have less recharge happening, but we don't really know. We haven't gone into level of detail to understand the impact to recharge based on hydrologic cycle, and I'll talk about that in a bit more at the end. Component that we've incorporated is sea level rise, and so for the time period that we're analyzing, then this climate change adaptation guideline by the BC MOE has 0.5 sea level rise. So we've accounted for it in our baseline or in our CO2 model run. Next couple of slides will go through the results. I want to give everyone a chance if there are any questions about how this is all formulated, these scenarios. Please feel free to jump in. We'll continue moving forward, but be shy. So this shows the baseline results. So from scenario 1, showing the capture zone. So we have the capture zone from there, 5-year, and 10-year. And basically the capture zones represent, if we apart at the surface, the time it would take to reach our well. Matt and Margot, do you have anything to add to that?
Well, I was just looking at this and thinking there's a couple of individuals. I think Dave wasn't part of the technical webinar one, and I'm not sure that I received an opportunity to really go through it but remind you of the conceptual model understanding. The aquifer is a deep sand aquifer, overlain by some till that does have windows of vulnerability. So there's also some complex sand till layers above that, and then we have the continuous capstone sediments and bash and drifts that kind of a continuous till along the surface. So this capture zone represents the time of travel. So a 1-year capture zone is the time of travel to the top of the confined layer above the aquifer. So it's the concept of capture zones is that theoretically, if you dropped a part of water on the surface at this point, this is the time that it would take to travel here. But this is actually a conservative capture zone because we don't include travel time through that those upper layers. This is the time when we get to the aquifer. So it's a conservative estimation of the capture zone.
And this next slide shows the capture zones for the climate change scenario. And in general, the capture zones don't change very much between scenario 1 and scenario 2. In terms of our analysis of the results, we looked at the drum at each of the wells for the city of White Rock to help or just to identify any risks to operations. So we looked at drum at each, or the water levels at each of the wells compared to the top of the well screen. So that's just part of our analysis of the data, and generally we see that the water levels never drop into the screen intervals for those operated by the city of White Rock in the future. We also looked at the effect on the water table on pumping just solely by the city of White Rock and then pumping by the city of White Rock and Surrey. And let's let Matt explain the next 2 slides.
As you explained, a bit of a comparison between the scenario with and without pumping at the Sunnyside aquifer. The Sunnyside wells, the screen currently right now shows pumping just the city of White Rock wells. This version of the scenario shows what happens when pumping at the city of Surrey wells is included. It's worth noting that the magnitude of drawdown within the city of White boundary is particularly different between the 2 scenarios, but it is worth noting that the drawdown from Surrey wells is predicted in our simulation to reach the city of White Rock area too.
Yeah, thanks. So this just shows that there is a need to have a coordinated effort because pumping the White Rock and Surrey will affect each other. Okay, so I guess our results on the predictive modeling, and now we'll jump into the sustainable development aspect of the protection plan.
I just before we jump into that, taking advantage of the fact that Kiki's on the line, Kiki, did these results differ from what you would anticipate, or what studies have been done in the city of Surrey?
We've not actually done any study on what would be the likely drawdown on the aquifer and the impact on the aquifer level. We have not done any study to reflect that, and I think it would be a good idea to identify, say, well, what is the impact of the additional pumping by City of White Rock, and what would be the impact of pumping by Surrey, and then the combined impact.
Yeah, I think that's an important path forward. You know, I also just when at these graphics, you guys haven't gone to this level at this point. I also highlight, you know, this this is the predictive model result. Because it was unavailable from the City of Surrey, those of Sunnyside number 2 and Sunnyside number 3 in the City of Surrey were used for calibration of the model, which is why you also see these really nice things of drawing around those wells. As the City of Surrey advances some of that work, and this highlights again the coordinated effort between the two municipalities, improve this whole understanding, and that will significantly help the planning moving forward.
One of the things to bear in mind there, Margot, is that this is an expectation. You fully expect that wells will be working for the same water. This is not a surprise in hydrogeologic terms. So it's a very important message when you go public that this is actually meets expectations. How you would refine it is a different matter, but this is perfectly aligned with expectations.
Okay, thanks, Lucian. Okay, so sustainable development. Because aquifers don't follow any sort of political or municipal boundaries, then there is this need to understand the different levels of governance and what will they play in managing water. So we identified on this slide, I guess 4 levels. So we have federal, the federal government is responsible for select water management responsibilities, and those that are not directly related to water extraction but are interconnected include commercial fisheries and fish habitat, and their use on First Nation land. Provincially, the BC government has the lead jurisdiction for setting policy, users, and managing water sources in BC. So this was recently strengthened with the passing of the Water Sustainability Act, the initiative that has been started by the government back in the mid-2000s. Local government also has some control over water. This is primarily through land use planning and water resource development. There's also community groups and nonprofit societies, so such as the Great Basin Council, for example, that can lead in the planning for water use. And nations are also involved, so consideration of traditional use, and then also incorporating traditional and ecological knowledge. So for us to move forward with planning, then it's important to understand the risks associated with groundwater use, and we've used a risk-based approach to determine the mitigation measures and also prioritize the action items. Consider current mitigation measures, and the approach we've used is based on groundwater hazard identification and a risk matrix. So for the risk matrix, we've considered likelihood and consequence. I'm sure this is I guess we have to use a more rigorous approach and try to I guess be a bit more transparent with the and remove some of that subjectivity, but of course there's always a bit of that to it. But let's go on to the next. I don't know if many people are familiar with this of risk classification, but basically when we talk about a risk matrix, this slide shows the likelihood on the left-hand side. So we have likely, possible, and unlikely. And then on the top, we have the consequence. And in order of consequence, we have low, moderate, and high. So in our approach, we would identify what the likelihood of this ground hazard having an impact. So in the example, I have it highlighted as B as possible. And we would look at, okay, well, what is the consequence? And if we say in this example 2 moderate, then overall our risk classification would be moderate. So where shown here corresponds where the increasing likelihood and consequence intersect. That is, and gives us the risk classification. Now, it is important to understand how we define each of the likelihood and the consequence. So the likelihood, unlikely, possible, and likely is mostly based on professional judgment, but the consequence, we've tried to add a bit more of a framework to that. So when we look at consequence, we basically have two criteria. So we look at it groundwater hazards for quality and groundwater hazards for quantity. And when we look at the quality hazard, then we apply the concept of we have to have a pathway, a source, and a receptor to have risk. In our case, the City of White Rock wells are always the receptor. In our review of the data for the pathway, we look at the thickness or the continuity of the low permeability unit above our aquifer. And for it to be low, then that low permeability unit has to overlie the aquifer. We have a source. And moderate, then in our conceptual development, we have these windows within the confining layer above our till, where there's potential for contaminants to migrate into our aquifer. So if that is where our source is, then the consequence, we've assigned it as moderate. For a consequence, they have to have an unconfined aquifer, which we don't have in our study area, but we just have included that to provide, I guess, a comparison. But we may have preferential pathways to aquifer. So this, for example, abandoned wells, where we have, if there is a contaminant source at the surface, then it can get directly to our aquifer through the well casing.
Just before we move ahead, in the previous technical working group, we identified wells that were part of the provincial water wells database that were put in or constructed prior to 2005 as being potential sources, unknown whether these wells are abandoned or not, or if they're active. But they have some guidance as to where some of these likely preferential pathways may exist.
Right, and those have been highlighted is because prior period groundwater protection regulation was in place, so there's just more uncertainty on the integrity of those constructions. And just to highlight what I've discussed here, this here shows the till lower unit in red is the same graph, the Sunnyside Aquifer, and then above that in green is the till. You see the lighter green color. This is where these windows that we're talking about in our consequence analysis, this is where they may exist. I also considered the capture zone, where the source is located with respect to the capture zone. So 10-year, 5-year, and 1-year capture zones have an increasing consequence. And then that we've included that is because we want to prioritize potential sources of contamination in the 1-year capture zone and help with our action item prioritization. Our action item prioritization.
Could I ask a question there, Zidra? Yeah, could I? Yeah.
Sure.
Okay, so with the 10-year capture zone, is that an artifact of attenuation? In other words, you'd be saying to yourself that in a 10-year time frame, a certain contaminant, like say petroleum hydrocarbons, would attenuate out, versus ability to monitor the arrival of a contaminant in transit. So where do you see the distinction between 10 years worth of attenuation versus ability to detect a contaminant in a 10-year time frame?
We haven't included any, say, attenuation potential. So, again, from that perspective, this is more the conservative side.
the next step. So now, and you'll see this as we go into the discussion on risks, because some of the risks that we've identified are the location of these sites that higher potential for contaminants to be present, or actions taking place on those sites that may put the area at risk. And that next step can be then looking at, well, what are those contaminants, and then what is the natural attenuation of those contaminants, how would they travel? But for right now, we're looking at defining what are key risks to plan for. And so we had looked at that detail.
That's good. That's absolutely relevant. Just to bear in mind that if something is in transit, if there's no monitoring, then to mind low wouldn't apply. But I take your point that if there's good attenuation potential, then that does reduce it to low.
Okay. If we look at the second criteria, which is quantity, then we've looked at this in two aspects. So there's the operational side of quantity, and that's we look at White Rock would like to maintain at least 1 meter of level above the top of the well screen. So we've included in our risk analysis three levels of consequence. If it's less 1 meter above the top of the well screen, so to the far right, then we have a high consequence because that doesn't meet the City of Rock's operation criteria. If we're between 1 and 5 meters above the top of the well screen, then we've classified that as a moderate consequence. If we're above 5 meters of the top of the well screen, then it's a low consequence. We've also considered model sensitivity. So just to, recap from the first webinar, we had our model, the way that we're introducing water inputs is through recharge, but we also have this eastern boundary where we're including water into our model based on our calibration. So when we went our first iteration, if we just included recharge, then we weren't able to our steady state calibration. So we had to add. So conceptually, we revised our model to have input from the eastern boundary so that we have better, better with the water levels that we have for calibration.
This was based on observed water levels that were deemed to come from a common aquifer outside of our model domain.
Mm-hmm. So these introduce some uncertainty where that affect our groundwater hazard analysis. So if the parameter, for example, recharge, has a low change in the model response, then we've classified it as a low consequence. If the medium, this is all relative, if there's a medium change in the model response, then it's moderate, and then if it has a high change in the model response, then we've classified it as high. And we've applied, it's a little bit, I hope it's easy to understand. It is a bit more of a complex way of doing risk analysis, but it just provides more rigor into the approach. So based on using that risk analysis framework, we identified 22 groundwater hazards, and this figure below summarizes the outcome of that analysis. So we identified any hazards that have that are likely and have a high consequence, or actually any hazards that have a high consequence. They either low, moderate consequence, and the likelihood can vary from unlikely to likely. And for the purposes of this present, we're just going to focus on the top. I think we have 6 hazards. So this maybe summarizes a bit more of some of the things that we've considered. So
I'm just going to interject a little bit. So this is our, based on conversations with White Rock, based on our understanding of what potential risks may be, or groundwater hazards may be. We came up with these 22, but if you yourselves, as experts on the phone, have comments or concerns you want to be captured as well, please voice them so that we can also consider them in the risk assessment and see where they come out in our classification.
It'd be worth putting like the results analysis to have a bit ability to provide feedback, I guess. Okay, this table, groundwater hazard is shown on the left, and the color corresponds to if it's a high or medium risk. So high is red, and then medium is yellow. We've included a brief description on the possible effects if that groundwater hazard was to occur. Is quantity or quality, which was discussed previously in the risk matrix. We've also included a column on scale. So who does this apply to? Is it just a White Rock issue? Is it more of a regional context, or should there be some involvement from, say, at a provincial level? And this is all sort of draft and preliminary, and definitely worth having a discussion. We also highlighted some of the current mitigation measures that we've considered, and we show the likelihood. So the A, B corresponds to what we showed previously. Oh, sorry. One more. So likely, B possible, C unlikely, and the 1, 2, and 3 corresponds to low, moderate, and high consequence. Okay, and we also have included the new mitigation action that we propose. So, I guess the groundwater hazard that we've identified as the priority is what happens to that eastern model boundary. And so if there's a decrease in the boundary, then we could have a decrease in groundwater quantity. This could result in user conflicts, and it would also result in a larger capture zone. So we have in place right now to address that. So we have a couple of regulatory controls. So the Water Sustainability Act, we've got licensing in place so that provincial government will know when new users or major users come into that area, then they can ensure that's reviewed before licensing is granted. We also have an Environmental Management Act that controls the assessment process depending on the volume that needs to be extracted. The provincial government has water science series, so a funding in place to advance the understanding of groundwater in the province. And then we also have the observation well network. And I don't have a well in the Sunnyside Aquifer area. We do have wells to the east. And so we propose that the new action should include evaluating the connectivity of the Sunnyside Aquifer to adjacent aquifers in more detail. And really more of a regional context is required. And so there needs to propose formation of a regional groundwater committee. So that could include different stakeholders, you know, from the local to the provincial level, to a coordinated effort to manage groundwater. On that risk, that hazard.
Yeah, so I think that was some excellent ideas in there, Zidra, especially the regional perspective, because as you saw from the compound drawdown cones area, that Surrey and you've got City of White Rock drawing upon the aquifer. So really, it all matters in terms of stakeholders, and it needs to be looked at from the regional perspective. I have to agree that if we consider the criterion that's being applied to the well, which is the 1 meter above screen and so forth, to my mind, it wouldn't be so much the production well, but more what's happening in observation wells. Production can become compromised by other factors such as decrease in efficiency due to incrustation, for example. Whereas a decline in observation wells would actually mean something happening at the aquifer level. But I think you're absolutely correct, and the perspective has to be the stakeholders looking at the aquifer on a regional perspective.
Yeah, I think it's important to understand that that model boundary is very important in controlling groundwater or contribution into our model. So it requires that we define that better, and we weren't able to do that because of our intent. So it really needs more of a regional focus to get that model, or to get what's happening along that eastern boundary right.
That while a regional effort is a good idea to look at the impact of either the ground wells of White Rock and the future Surrey wells, and I think monitoring of some of the observation wells may be critical to know how to confirm that the charge is the right assumption, as well as the soil and the ground parameter to confirm the model sensitivity analysis is appropriate to the area. So you mentioned that there is a few observation well network. Is there somewhere that is documented in the report, or somewhere that what is the current monitoring effort?
So I haven't included a figure in this presentation, but there is, the provincial government has a website where you can go to and you can view the active observation wells, and some of them have real data that you can see, but that's all available. And I think particularly in the Langley area, they've been monitoring it for a long period of time, and they can, there's a decrease in the water level happening. But so that information is out there. I haven't explicitly included it in this presentation, but it's readily accessible.
No observation well within the aquifer as the Sunnyside aquifer is currently defined. Mm-hmm. So we talk about this model boundary. That's a result of our conceptual understanding of the system. The original model extent captured what was understood to be the Sunnyside aquifer, but it's clear that eastern boundary of that aquifer is being not as well defined as we would hope, and or there's clear connectivity to other aquifers to the east. If that's the case, that needs to be better understood, since that's a major contributor to water supply. Mm-hmm.
So move on to the next groundwater hazard. So we identified that a lack of public education and understanding regarding pollutant pathways to groundwater supply could exist. That could lead to inefficient use of groundwater and misconception. So that could, I don't think that possible effects, I guess that should have been more of a potential to contain the aquifer. I think that would be more appropriate. So that's there.
Effect would be mishandling of hazardous materials or application of fertilizers and pesticides, not using best management practices. So it's ensuring that people, particularly individuals in the capture zones that we choose to manage by, are well aware of mitigation measures that are in place to reduce that risk, and aware of what the impacts of their actions may be.
Right.
So, sorry, that would be absolutely correct, because you would have a non-point source, so you would have a gross loading from a particular urban area where residents were using certain fertilizers or whatever it is, and then you get that kind of broad loading of contaminant. The classic would be in eastern Canada is the nitrate leaching into groundwater, for example, from septic fields. So this, by analogy, if these fall in your vulnerability zones, so those residents would have to be given flyers and whatnot to advise them of actions and so forth.
Mm-hmm. And currently, the City of White Rock and the Fraser Health Authority have dedicated websites sites to talk about water quality issues. There are community hazardous waste collection programs, and there are also best management practices. And some of the mitigation actions that we have here are public awareness, so public house, pop-up displays, targeted groundwater user programs, so potentially like using flyers to educate the residential properties within the capture zone, and also signage in recharge areas to raise awareness.
I'm going to point out about the issue of the lack of public education, and that is what some people just go grab information from the internet or grab some tools from the internet to identify. They think they're identifying or doing analysis, which is not considered analysis, is not approved by Health Canada or EPA, and we've seen something like that came up about the glyphosate, and we went and we did tests at certified labs, and it showed below detection limits. So that's why, like, you know, the education of the public is important, and that's why, like, you know, what we're doing now is part of education, as developing these webinars and putting it in the website, then open houses, and we're presenting some of this work in the conferences, so people are aware about the issues that will be addressed.
It's absolutely very important, because what you find is that people at large, especially skeptics, will certainly go on the internet and they will selectively look at the information there, and they'll read all the negative publicity and will not look at the positives at all. So they're very selective, and that's why it's very important to counterbalance that with good information.
Okay. We have the hazard is identification of some types of businesses, so gas stations or dry cleaners that are within our capture zone. So I identified one capture zone, or sorry, one gas station that's within our groundwater capture zone, and I guess this just highlights, and same with the next couple of risks here, our top risks. So these are site registry IDs, and I guess this just highlights the need to potentially develop permit area guidelines to protect recharge areas, so have some mechanisms in place to that this gets considered when development progresses. And again, because not all of these may be located within the city of White Rock, then there is this need to have a regional groundwater committee to coordinate these kind of efforts. So if the city of White Rock changes their bylaw or implements something to protect their recharge areas, they won't be able to enforce it within the city of Surrey, for example. So the city of Surrey might need to consider some of the protection that city of White would need because their recharge boundaries extend into the area. So it gives need for a coordinated, collaborative effort between the municipalities.
That your suggestion of a regional groundwater committee or something similar to that would be really useful. Maybe while the committee or something would need to develop some sort of idea or guideline on how the future development land use in that area that may affect that are within capture zone or the recharge area, and which may impact on the water quality of the aquifer.
And so, you know, when we talk about integration and like collaboration, I guess it has to happen at multiple levels. So we have it within the municipalities, but each municipality also have different plans, say, to manage surface water, stormwater, to water conservation or water planning. So all these planning documents also have to be integrated. So if you're looking at changes or on how to protect groundwater, then what is your integrated stormwater management plan including, and the thing. So it's integration on multiple levels. But KK, that's a good. We have a slide that talks a bit more about that regional groundwater committee, and some of the things that you've highlighted are included in that slide pack. So we can
move on though, and not want to open up a can of worms, but I want to make sure that the way in which our risk is being classified makes sense to the technical working group, and we can incorporate any suggestions they have, and we welcome feedback after this seminar if you have a chance to think about it, you think maybe something should be looked at. But I just wanted to point out, particularly here when we look at the site registry ideas, most of these site registry locations are within all of them are identified here are within the 10-year capture zone, aerial extent. Some are within the 5-year capture zone, none are within the first-year capture zone, but that's why the level of consequence is shown as a 2, because in that 5 to 10-year capture zone and in an area where the aquifer may have, the aquifer directly above the Sunnyside aquifer may have those windows of vulnerability, or windows of increased permeability. So go back to that initial classification for quality. That's how that's coming into play in the consequence here.
Yeah, and I think it's also important to highlight that just because it's on the site registry doesn't mean it's contaminated, but it's just in there. So it's just something that needs to be investigated a bit further. So that could be mitigation action would be to a more detailed review of some of those site registries that are in the area.
Now, see, there's a key thing to bear in mind there with those registries. These industrial or commercial entities, whether it be a gas station or light industry, will be monitoring their groundwater, and that mitigation itself. So at the upstream end, you actually have groundwater monitoring, but one of the flaws in that is that groundwater monitoring can be very much of a generic nature. I've seen this in problems here whereby it's just same old generic groundwater monitoring, not looking at really what's happening underneath. In your case, you've got a major aquifer system, and it should be generic monitoring. The monitoring system that these entities have to do should be designed with the view that they're sitting over a particular aquifer system, which is your Surrey and City of White Rock.
And so maybe that highlights in the regional groundwater committee the need to pull in from someone from the Ministry of Environment who deals with contaminated sites, that they're aware that we have these capture zones and we may have these areas that they're looking at that could have impact on water use. So I think that highlights maybe our stakeholders.
Emphasize that enough is to avoid a generic approach in groundwater monitoring at light industrial sites and so forth that should really reflect the particular hydrogeologic conditions and sensitivities, vulnerabilities for City of White Rock and Surrey.
Mm-hmm. There's another thing as well. We need to, like when we present this information to the public, I don't want some kind of a misinterpretation about the water contamination. We say possible effect, and we need to say is currently an effect or not, like the mitigation. But in status, did we say there's already a contamination? Because they will take it. Some of the people have certain or specific interest. Say, okay, you have all these sites, the possible effect, and we don't say what is the case at the present time.
Yeah, so I think some of that can be addressed. So if we know the potential contaminants of concern at these sites, and if they have a monitoring program like Lucian said, that helps with mitigation. But then this might also be able to inform the water quality monitoring program that the City of White Rock does. So maybe periodically some of these contaminants of concern get tested by the City of White Rock to confirm that there's no impact. So that might be a way to, I guess, provide some assurance to the public.
But then also to indicate what are you looking for? Like if you look at thousands of chemicals, we're going to be looking for. That's why each site, if you identify there's a potential contamination, You have to identify what is the issue, so it would be investigated. In general, it's a concern because it will be open for people being skeptical about these issues.
Right. So you've got you monitor and you test the water, which is required. Now, I do appreciate though the arrival of a particular contaminant at a production well. It's too late. It's already there. That means that it's pervasive right through to the well field. If something is breaking down, something is in transit, it needs to be detected, preferably at source, which is why these at source monitoring systems are so important, or your regional observation well network is so important because then you can see things early. If it's already arrived at your production well, it's too late.
Yeah, I think it is important to highlight that, we have included it as a moderate risk, but the Sunnyside Aquifer has low permeability sediments at the surface. So this would prevent or would I guess minimize the potential of contaminants moving downwards and contaminating the Sunnyside Aquifer. So, for example, there are other aquifers, I believe in the Fort Langley area, that is unconfined, where if you had a problem at the surface, then you don't have that protection layer of your aquifer. But that's not the case at Sunnyside Aquifer. So it is indicated as moderate here, but we have to keep in mind it's based on our risk matrix, and it doesn't mean, so it's important to stress that we do have confining material or low permeability material at the very top that would protect our aquifer from, site registry potential concerns.
Yeah, why I think. I think that's why. The risk assessment need to be very specific for this aquifer and the type of contaminant of concern. Because of the it is an unconfined aquifer. How would the unconfined aquifer impact on this risk matrix? Because every aquifer or not every confined or unconfined aquifer would have similar impact on the risk model.
I agree with that because this is the way it's been presenting here is too general and a bit vague, and it's open to interpretation.
Well, I guess the information that's available publicly for, at this stage of the study is very general. So we would have to dive in a bit deeper and get the details out to provide a bit more, better breakdown of what each of these registry IDs mean. And
because if a member of the public have a knowledge, okay, site 16271, what kind of contamination is that? What kind of contamination you're looking at? Mm-hmm. We need to identify that in order to make sure, and also what is the potential. For example, going again to glyphosate, Health Canada in the guidelines indicate it's unlikely that it will penetrate into groundwater because it will be exhausted in the soil, oxidized, and all that. So this is why, you need to identify that. Just say, potential hazards in these sites, possible contamination. It's general. That's open to interpretation. You're listing here 7 sites.
Okay.
Yeah, I guess, the next step would be looking at that in a bit more detail. And we haven't shown it here, but you could show groundwater hazards after the new mitigation. And if we go and look at these site registry IDs in more detail, and, we have a better understanding of water on the list, then it could result in a lower risk classification.
Essence of the aquifer may probably change the likelihood to something. Instead of the likelihood is just say it is it is in the 2-year capture zone or 5-year capture zone, because capture doesn't mean too much because it actually tells that it takes some time to reach the production well. And well, I think the key is what is the likelihood of the contaminant would actually reach the aquifer.
Maybe we've been a bit too conservative in our risk matrix.
Making notes here. I appreciate the that feedback, and I see where it's coming from and how this is presented, and I think this is going to continue to be a challenge on how to effectively present this, because it is based on how we define the risk, the consequence and likelihood details. But I think, yeah, it is a good idea to take it that step further. The thing that needs to be discussed in the Aquifer Protection Plan, which we aren't getting into the details of here, when we talk about the mitigations and what they mean, is things like these, whether they already have some sort of monitoring in place, maybe as part of a development permit guideline, and one industrial user within our groundwater protection zone is required to have specific management plans, spill response plans, and they have to provide that documentation to the municipality so that it can ensure that it covers the price that it needs to. The details we aren't showing here in this discussion that I recognize and need to be part of the Aquifer Protection Plan.
Yeah, these are very good points, because absolutely the more and more the ground monitoring has to be married to a response plan, and that's why we're putting them out within the last few years, that there is a response plan. So you're absolutely correct that we have been a bit on the non-conservative side, because if an industrial entity does detect contamination at its site, then it would have to wantonly not respond to obvious contamination, and that contamination just is allowed to unfold. That can't be the case. There has to be, the response plan has to be there and has to be implemented. The contaminant will never hit the aquifer, because if it's anything that's heavy duty, it'll be detected and then should be addressed at source.
So, yeah, I think we'll review our risk classification matrix and make sure we're accounting for these existing mitigation measures already. So the source monitoring at the sites, the control that the BC government has on monitoring, or at least managing those areas. So we get further, that's good feedback to get, because we don't want to cause any alarm.
I'm just curious to know your choice of words here, in terms of in your matrix there, you mentioned it's possible hazard or possible effects, as opposed to perhaps potential effect. Is there a difference between those two words, or is it, because the way I look at it is that what you're saying here is that whatever is going on at those site registries, it's possible that it's going to contaminate the aquifer. But if I see a word potential, then it may be that there may be a potential there, but it may not be possible for that contaminant to get into the aquifer. So I don't know, maybe that might help to alleviate as part of SAD's concern that if some local residents get hold of this document and look at it and say, aha, see, there's a possible contaminant effect here. So what are you going to do about it? I don't know. Just thought.
Sorry, but the words absolutely matter, and working on a lot of impact scenarios, absolutely wordsmithing is you got to say the exact message, and weak words that could just add a weak selection. Every word has to be fussed when you go public, and if there's a more succinct word that captures the situation better, then that word should be found.
On our action list to review the wording of likelihood. Even provide some definitions for that to be a bit more clear. Okay, thanks for that. Let's move on to The next part is sustainable development. So there's a data collection component to it, and we have a few recommendations. So we have recommendations for the City of White Rock, and then we also have it for on a more regional level. So for City of White Rock, they have a monitoring program in place. So they measure water level, pumping rates, their SCADA system, and then they also have a regular water quality sampling program. We recommend to add some additional parameters to complete a geochemical evaluation of the source water. So right now the program is focused on drinking water quality and ensuring that that is assessed relative to the drinking water quality guidelines. So to take it one step further, then we would add some parameters to get a better understanding of what's happening in, or better characterize the groundwater itself. So that's where that would help us understand where groundwater is coming from, the source of groundwater, a better understanding of that context, more of a hydrogeological context, and a treatment or safe water perspective.
And if these parameters are collected regionally, not at the City of White Rock wells, then it really gives us a better conceptualization of the overall aquifer across the region, rather than point search.
Well, and the hydrogeologists look at that water quality in two different ways, and the prime way for the municipality, of course, is, well, what's the water quality? Can we drink it? But hydrogeologists don't necessarily look at water. That's an end point. We look at the water. What does the water quality tell us about? Where did the water come from? How did it evolve as it moves through the aquifer? Because it absolutely takes on the character of the aquifer before it gets to the end point. So hydrogeology uses various parameters to assess what the aquifer is doing by virtue of its hydrochemistry. The quality as an ability to drink it is kind of to us, not even the scientific end, though obviously it's very important as people are consuming the water. But there really is two completely different things going on there. There's the ability to drink the water, and there's the ability to assess what the water is telling you from a scientific perspective.
And I also would recommend some data management to facilitate analyzing and sharing of information. So as more data is collected, it's important to have it in a format that is easy to distribute, and especially to provide continuity in the monitoring program. So I mean, we just see that as a increasing challenge for collecting large amounts of data, and how do you manage that so you can use it efficiently when you go to assess it.
I just want to comment here about the additional parameters. Is there certainly, like, is it for when people apply for a development thing, they need to do that, or that's a regular basis? Because on regular basis, as Mark mentioned, we follow Canadian guidelines for drinking water. We do this on a regular basis, like alkalinity is done all the time. ORP is not a regular thing need to be done, but it depends what you're doing. It depends on that. For if you're at a sustainable development site, when it's going to be done, they have to go and do these certain tests because another drinking water requirement.
I think that just highlights what Lucien was talking about, how from a hydrogeological perspective, I guess there's a different approach to analyzing water quality compared to what you would need for drinking water purposes. So I think there are a substantial number of parameters. The City of White Rock is monitoring most of the ones, so it's just a few tweaks here to make it complete for geochemistry.
That one, QA and QC compared to what? Because certain analysis, you double check it to compare to. So you're setting a standard and you compare it to. So which one you're looking at here? Like in our analysis, QA and QC, we do it, then we a split sample to do that, to see if there's any change or see any other parameter impacting. but we have to be very specific when we say that a requirement for development to do these tests, and because it's too general when you say I'm balanced for QA/QC. What are you looking at? What QA/QC? These are again open to interpretation.
Yeah, and in the groundwater protection plan, we'll provide more detail. I mean, we've just kind of left it more high level for the purpose of the presentation, but the detail will be in the groundwater protection plan. I guess just to put ion balance for QA/QC is just sort of a test that we do from a geologic perspective, where when you touch the water, it doesn't give you an electrical shock. So do an ion balance to see that that is, I guess, neutral. And that's just a measure of test or just reviewing the data supplied by the laboratory to have some confidence in it.
And we do conductivity tests that's regular as well. If you look at annual reports, it shows annual conductivity on monthly basis. It shows also the alkalinity on regular things. So that's what, like, you know, things are duplication here. I think we need to say very specific what you require. Oh, you're not doing alkalinity. Well, we are. Yeah. And the report shows regularly. Done regularly.
Okay, we'll definitely refine these then. And again, this is just preliminary, and this is for discussion. So we can make sure we get the right parameters in there, and that we're not doing any duplication. Okay. And now data collection from a regional perspective. So our thoughts are to include some mapping of springs and seepage areas. So I understand from talking with the City of Surrey, along the northern part of our model boundary, there is potential for some springs and seepage, and we haven't captured those in our conceptual model. There's also recommendations to evaluate geophysical survey options to address some of the geological data gaps we had. We recommend establishing an observation well in the Sunnyside Aquifer, and this would be in the provincial network. But most importantly is establishing a regional monitoring network, and that would include select private well owners or other wells in the area that can be used or that people like to participate in to augment the provincial network. We also have aquifer testing of the regional monitoring network, conducting some flow measurements in the creeks and rivers, and this will help us identify recharge or discharge areas, and then also doing a more detailed regional recharge study. Okay, so our last component here is just a bit, some point on what the Regional Groundwater Committee, just framing that. And so we see it as a way to have coordinated governance and management. And it would be a way to implement groundwater management, but you need to define the goals, targets, goals, and establish some funding mechanisms. It would be developing a groundwater working group to administer network and communication results, and that would be part of the management side. Could include assessing potential cumulative impacts to assist with sustainable resource planning and strategic management decisions. And so that would include using a model as a tool to help with that planning or that decision making. And so the Regional Groundwater Committee, one of the roles could be the owner of the regional groundwater model, managing that and being responsible for updating that as new data becomes available. Also design and implement a groundwater monitoring network as per the management strategy. So really we had sort of three main components: managing, the modeling, and the monitoring, to provide a way to move forward with sustainable groundwater development in the area.
That's kind of what we wanted to cover off today, and I know that we've gone a little bit over what I was hoping to do for the length of the presentation, but I appreciate the feedback. There's a lot of content here, particularly in the last few slides as we're going through discussion. So please, I want to continue having discussion now, if people are able to stay online for a little bit. If not, I also welcome email response or feedback or phone calls. So our contact information is provided here if you'd like to get in touch with us or follow up on anything. I encourage that. But I'm just going backwards a little bit to the previous slide. Just try and I guess some feedback on these, and also just hint, these are our draft recommendations that we're building into the Aquifer Protection Plan that I think are pertinent to consider. The wish list of can and could be done to move forward, and obviously need to prioritize how that would happen and what it would look like, and that's maybe the next step, is starting to get that coordinated governance and starting to define some of those goals and targets. But are any comments from those online about what this looked like, or if you something overreaching?
Definitely have to have, and gravitating towards a plan. It's like when you buy a new automobile, you get a service booklet that comes with it, usually quite thick, and it sets out the mileage at which you've got to change your oil and so forth, or when you've got every second year you've got to do a major service and whatnot. That's all laid out for, whether it be a Ford or a Chev or whatever the model is. You get an instruction manual, whether the individual will adhere to that and change their oil every 6 months or whatever the booklet says. But there's definite guidance from the manufacturer as to how that automobile should be serviced. We have a very sophisticated water supply system, and it needs its service manual as well to cover many aspects that you've covered in this presentation. And this is what the slide, to my mind, kind of captures, how to put that all together.
Yeah, it is important in the, in previous slide of this, you list our quite a few recommendations. And I think it is important to identify who would be going to be the owner of these works, because most recommendation, the impact would be with City of Surrey, because the majority of the capture zone are located within City of Surrey. So whether it is monitoring, whether it is the control or of the potential contaminants from the source, or any remediation if some contamination did occur, they likely quite a good number of them would be happening within City of Surrey. So I think that would be quite a I will need to bring this back to the other department within Surrey, because most of that actually would not be directly related to our drinking water system. And but the impact on the aquifer is, of course, as we know, would have impact on the aquifer. So what would be the next step on this? Once we got complete this technical webinar, before the final report, what would be the next steps on this project?
So this project are to now take the feedback that we received from today and anything that may come through the next few days, for a draft, which will go to the City of White Rock for review and comment. If they would like to share that to others for review and comment, that is something that may be discussed with SAD, but that is SAD's call to make, because this is their plan for how they're managing their system. And then would be going to a public open house to present the characterization of the for the existing mitigations that are in place and next steps for securing that groundwater protection zone, and the recommendations related to that. That will be discussion, I guess, that we can continue as far as what is presented along the lines of where it's going to move for a region at this point, since that's unknown, but that is just a recommendation. But those are the next steps, and then it will be, following the public open house, we'll be finalizing and presenting to City of White Rock Council.
Part of having this technical working group, you know, we can start this discussion, but obviously the regional, any regional work will have to be initiated, but this just kind of starts the discussion, and how it gets implemented, that needs to be worked out in the future.
We talk here it's strategic, and from experience we had in Ontario, and after the Walkerton situation, the province established soil water protection plans and divided it into 19 regions in Ontario. So each region had soil water protection, and the province, and just we'll go back to the point Kate mentioned about the owner who owns and all that. It has to be a regularity group, directing the effort, because you don't want that to be a sporadic and nobody's no contact with whom, and that's why I think the province need to be involved. When we say regional things, we have to have a discussion with the province about this issue, because this is important for the public health, and all regions in the province has to be involved. Like, it's a start here. And this is a roadmap we need to be talking about here.
Definitely.
Yeah, it's important that, well, when this final report is published and as well in the open house, the message to the public should be very clear, and then it will be consistent between the various stakeholders. So I think that need to be further discussed, because otherwise the public may have a different perception and different interpretation of the document.
Well, and I think to address some of this, the governance issue, we'll reach out to Mike and we'll specifically ask him what the province is planning, or what their thoughts are on these sort of regional issues and how they plan to manage it. And I think it's a new thing for them, because they're dealing with water allocation, so they have to have something in place to address, not what's acted at a well, but regionally and cumulatively what could happen. So we'll go to Mike and get a bit more feedback on him, and we can include that in the register that we have for this workshop, and so that kind of information is shared with everybody.
I agree with you that that message has to be consistent. So we will definitely work to prepare the materials for City of White Rock's open house and for their aquifer protection plan, and we'll work through STAD on how that is distributed to others to confirm content and input. Is that? Okay, are there any other additional comments that anyone has before we sign off of this session?
Well, a couple of points. We take them offline if you wish, Margot, as a more directly technical, or if you think this is the right forum, we can do that too.
We can do it offline. I'm just cognizant of people's time here.
Yeah.
Quite a bit over.
Okay.
All right. Well, I really appreciate the time that you've taken to participate in this discussion. As we said, as following up on what Peter said, we are going to be sending this presentation to Mike Simpson, who is hoping to participate. So we're hoping that he will also have some feedback that we can incorporate. Similarly to how we did the first technical working group, we will summarize some of the comments that came up and address, pull out the action items from that, make sure that they're considered for the preparation of the protection plan. This will be distributed to all that were invited to the technical working group for review and comment. This webinar will be posted on the City of White Rock's website, and when the comment tracking table and the comments received through these discussions will be appended to the aquifer protection plan, so that it's we're transparent in what the dialogue has been to the plan. So thank you, everyone. And
thank you.
Please, as we said, please email us if you have additional comments.
Thank you.
Thank you.